Alright, so after watching the first video, let's take some time to see these concepts applied. So we're going to talk first about linear depreciation. So a web server has an original value of 10 grand that will depreciate linearly, so we can use our linear model, over 5 years with a $3,000 scrap value. So a $3,000 scrap value means that at the end of the 5 years it'll be worth that much and it will no longer decrease in value. So we want to find the rate of depreciation. All right, depreciate means to lose value. So our value depends on the time. So as soon as we write that sentence, we know that the value is our y and the time is our x. So the change in y over change in x would be the change in value over the change in time. So what's our change in value? Well, we had 2 points in this problem here. At year 0, the value is $10,000. At year 5, the value is $3,000. So we're going to do 3,000 minus 10,000 over 5 minus 0, which gives us 7 grand over 5, which is, or negative rather, negative $1,400 per year. So the units here are dollars per year. All right, keep the units because that helps us remind us of the context, and it also will help us interpret certain things, or more easily solve some of these problems. So what does it mean in the context of this problem? It means that every year the value goes down by $1,400. All right, and I did this out, but you could have just looked at it. You know, it's losing value. 10 grand to 3 grand is negative 7 in 5 years. So negative 7 grand over 5 is negative $1,400 per year. So let's find an expression. So we're going to use the y equals mx plus b. We have the m and we have the b too. This is our y-intercept, right? So its initial cost or initial value at year 0 is 10 grand. So that would be our y-intercept. So that gives us v of t equals negative $1,400 per year times number of years. Oh, I should use t. 1,400t plus 10 grand. So what's the value at the end of the second year? Just plug it in. We're going to plug in a 2 here. So this is where the math occurs, 2. So we get negative 1,400 times 2 plus 10 grand gives us $7,200. So that's how much it's worth at the end of the second year. Alright, so another important example are profit functions. The profit functions and the supply-demand functions we're definitely going to harp on a lot. So we're going to let x be the number of units. And we're also going to assume that all units made are sold. Alright, that kind of simplifies a lot of our calculations. So the total cost is going to be the fixed cost plus some cost per item x. Alright, so this is our fixed cost, and then this is the cost, or the variable cost. Alright, it's a variable cost because it varies depending on how many things we make. Okay, and then our revenue function, revenue is the total money paid for your product. It's not the total money end up in your pocket at the end of the day, but it's the total money that other people give you for your product. So that's going to be the sales price times x. Alright, and then the profit function is going to be your cost, or rather, it's going to be your revenue, all the money you get paid for your product minus the cost, right? Minus what it costs you to make the product, and that gives you your profit. Alright, so let's see a fairly generic profit function problem. So the numbers aren't disguised too well here, just pick them out. The Puretron manufactures water filters at a monthly fixed cost of 20 grand, production cost of $20 per unit, and they sell their filters to the distributor for $30 per unit. So the cost function, C of x, is going to be what it costs in total. So their fixed cost is 20 grand, and then their variable cost is $20 per unit. So that's going to be 20,000 plus $20 per unit. That figures out their total cost. Their revenue function is, right, because it's fixed cost, variable cost. The revenue function is how much money they get paid based on how many units they sell. So that's $30 per unit. So 30 times X is their revenue function. Their profit function is going to be the revenue, total of money in, minus the money out, the cost, and that gives them 30X minus the whole cost function, so minus this whole thing here. So it's minus 20,000 plus 20X. Distribute that, and you get 30X minus 20,000 minus 20X, which simplifies to 10X minus $20,000. Right? So if their fixed cost is 20 grand, they sell 0 filters, their profit would be a negative $20,000. They're losing money if they don't sell any filters. So if they sell 1,800 units, are they in the red? This in the red, what that means is it refers to if you actually graph their profit versus number of units they sell, it's going to look like this. Initially, that's the $20,000, right? They sell nothing, they're going to owe $20,000 because that's a fixed cost. It's always there. They sell a bunch, they make some more money back until eventually, and you see they're selling them for more than it costs them to make them, they hit a break-even point, and anytime you're losing money, you're in the red. Once you start making money, people say that you're in the black. Alright, so this is a profit that is more than 0, means it's positive. In the red would be a profit that is negative. Alright, less than 0. So basically we're just trying to figure out, is their profit positive or negative? So they sell 1,800 units, you just plug it in. P of 1,800 is 10 times 1,800 minus 20 grand equals negative $2,000. So that means they're in the red. If we plug in $2,000, you evaluate that and you actually get 0. So they're neither in the red, in the black, they have broken even. Alright, that's called the break-even point. And then the third one, plug in 2,400, and that gives us a profit of a positive $4,000 in the black. Alright, so that's a profit function. Let's look at supply and demand.